Hello, guys. We are now on the second part of 8.1, which is geometric mean in right triangles. Uh, on our first video, it was entitled just geometric mean, and all I did in that video is explain to you what geometric mean is and how it is done. Now, part two of 8.1, we now use geometric mean to solve right triangles, just like the triangle that you're looking at the whiteboard. So, the biggest triangle here happens to be right triangle. And then if you draw the altitude of this big right triangle, we create two more smaller right triangles. So this triangle on the left is a right triangle, and this triangle on the right is also a triangle. So essentially, we have three different right triangles. And because they are all right triangles and they happen to be originating, um you know, from this circumstance, then we can safely say that all three of them happen to be similar right triangles. And because they are similar triangles, then that means that their corresponding uh, side or sides are proportional. So I'm gonna remind you of the formulas that I gave you last week. And but before we do that, let me represent or label the sides of this uh, diagram. Say this one happens to be A, and this one is B, and this one is say C, but I'm gonna break it into two. I'm gonna call this one my X. I'm gonna call this one my Y, and of course the whole thing is the C, and then say this one is my H, right? So I labeled all the uh, side lengths that I can identify, and including the altitude of the triangle. Well, the three formulas that I gave you last week on Google Classroom uh, can be represented also this way based on the triangle that I drew on the whiteboard. Uh, the altitude h, the altitude h, when you square it, this altitude here, h, when you square it, that's just equivalent to x times y. So the square of the altitude is just equal to the product of the two parts of the hypotenuse. Remember, if this is a right triangle, this one here at the bottom happens to be the longest side, so this must be the hypotenuse, and that altitude here kind of breaks it into two smaller segments. Well, the square of the altitude is equal to the product of the two parts of the hypotenuse. This is one of the formulas that I gave you last week. And then if we look at that side A over there, if we square side A, which is one of the legs, that A there, if you square it, will just be equal to this side X, this side here adjacent to that side, multiplied by the whole hypotenuse. And the whole hypotenuse is X plus Y. So one more time, A squared is equal to X times X plus Y. One more time, A squared is equal to x times x plus y. And that's what I wrote over here. Maybe I don't need to put these times here anymore. It's understandable anyways. And similarly, if I square b, if I square this leg, remember a and b are both legs, right? And b is another leg. And if I square this leg, that will be equivalent to the adjacent short side of the hypotenuse, which is your y, and then multiplied by the whole hypotenuse, which is x plus y. So one more time, b squared is equal to y times x plus y. a squared a squared is equal to x times x plus y. So technically, these two formulas are just one and the same. A is a leg, and so is b. And the way to find a squared is the same thing as b squared. So the only thing kind of different here is finding the altitude. So the altitude, which is the height of the right triangle, the square of h is equal to x times y. We're good? Now, I know I wrote the formulas last week using um, different variables, but they were essentially the same. I just used different labels on my right triangle. That's why the formula looks like this. One more time before we do examples. So we are given a right triangle, right? A big right triangle over here. And then when we draw the altitude, we and then we ended up breaking it into two smaller right triangles, and now we have three right triangles in one diagram, and those three right triangles happen to be similar, and because they are similar, their corresponding sides are also proportional. So these formulas here, the three formulas that I wrote down, um, are products of proportionality. And I am not going to show it to you anymore, but one of the videos that I'm going to be posting will show you how these formulas are derived. So these are the three formulas. And before I give you specific examples, let me explain to you why they say geometric mean in right triangles. And you're probably wondering right now, where are the right triangles? Where are the geometric mean? Well, if I take the square root of both sides, this formula will turn out to be h equal to the square root of x and y. Now, doesn't this look familiar to you? This essentially tells you that the altitude of the right triangle is equal to the geometric mean of x and y. The altitude of the right triangle is equal to the geometric mean of x and y. Boom. Now let's take a look at this second equation. If I take the square root of this, that will just leave us with an a. And if I take the square root of this, it will give me the square root of x times x plus y. So that one also looks familiar, right? It, it essentially tells you that this side here is equal to the geometric mean of this side and this side. So here's x plus y. So a is just the geometric mean of this and this number. We're good? And this is the formula. And similarly, this formula can be converted into b equal to square root of y times x plus y, which essentially means that this leg is equal to the geometric mean of this number times this number. So uh, now, if you're wondering where the geometric means are in right triangles, these three represent the geometric mean that we are talking about inside right triangles. Any questions so far? So let's summarize it one more time. In my with my past students, this kind of helped them. Uh, the altitude the altitude of the right triangle is the uh, geometric mean of this number and this number. This leg is equal to the geometric mean of this number and this number. This leg is equal to the geometric mean of this number and this number. We're good? Let's look at some of the examples, um, example applications. So um, we can develop our confidence in solving those problems. While I'm erasing the board, well, let me see. I'm just going to erase the top one. I want you to look at the examples on page 6 of your packet. Page 6 of your packet is just the second page of that packet. So let's look at problem number 1. So exercise number 1. And the triangle looks like this. So here's the right triangle. I make sure that it is right. And then the altitude is represented by x. The hypotenuse is broken into two parts. And this part is 1 and this part is 3. This is exercise number 1 in your packet. Let me draw some line over here so um, you can focus a little bit. Okay, so here's example or exercise number 1 in your packet. Notice that the x represents the altitude of that right triangle. Which formula do you think applies to that one? It's the one with the altitude, right? So according to this formula, x here is just equal to the square root of 1 times 3, or the altitude is the geometric mean. The altitude x is the geometric mean of 1 and 3. So to find geometric mean, you multiply and take the square root, right? What's 1 times 3? 1 times 3 is equal to 3, and you cannot simplify that one anymore. Therefore, square root of 3 is our final answer. Final answer. And what does square root of 3 represent? The measure of that altitude in exercise number 1. So one more time, uh, this problem involves the altitude, and among the 3 formulas that we have, the one that involves the altitude is the first one, so I used um, the first formula. One more time, that altitude is the geometric mean of these 2 parts of the hypotenuse. Any question? Let's look at problem number 2. I like problem number 2 because it's multi-layered. It is multi-layered, and I want you to be to stay with me. Uh, One reason why this could be challenging to you is the fact that it's not oriented. The diagram is not oriented the way my right triangle is oriented. We didn't have trouble with the exercise number one because the diagram in the problem is oriented the same way as my um, example, but in exercise number two, woo, it's different. So stay with me. So here's the right triangle, right? And then the height is of course given this way, right? And then it's gonna make 90 degrees with the hypotenuse. So the hypotenuse is now here, and that altitude happens to be x, and x, which is the altitude, divides the hypotenuse into two parts, 2 and 5 units. And then this leg is y, and then this leg is z. Now it's multi-layered, as I mentioned earlier, because we need to find three variables, not just one. Um, you're probably gonna choose to do x first, right? You agree with me? See, if you solve for x, that would just be the same as the exercise number one. So x would be equal to the geometric mean of the two parts of the hypotenuse, which are the 2 and the 5. So x would be the square root of 2 times 5. And 2 times 5 is equal to 10. Therefore, uh, let me see. Can we still simplify this radical? I don't think so, right? So this will be your final answer for x. Are we good? Now, which one do you choose to do next? Y or Z? Well, both of them are legs. And the way the problem is presented, it's not going to make any difference. So let's solve for Y. So I'm going to, okay, solve for Y. Can you still see it? Okay, I'll make sure that you can see. Okay, so I won't be in the way. So solving for Y, notice that Y is a leg, so it's either A or B, right? And so we can use any one of the two formulas here, but we already know that these two formulas are just one and the same anyway. So let's solve for Y. So Y would be equal to, or Y is the geometric mean of the part of the hypotenuse closest to it, which is 2, multiplied by the whole hypotenuse, which is 7. Are you lost? Okay. You're probably wondering where I got the 7 from, right? Because there's no 7 in the problem. Well, let me go back to this one here. Um, A is a leg, and to find the length of A, you need to get the square root of this number, sorry, the square root of this number times this number. So the whole thing. So that's why I have x plus y over here. So y would be equal to the square root of 2 times 7. And 2 times 7 is equal to 14, and square root of 14 cannot be simplified anymore, so you can have this as your final answer. Let me give room for Z. Now for Z, Z is also a leg, so it doesn't matter which one of the two. So Z would be equal to the square root of the part of the hypotenuse that is closest to it, which is 5, multiplied by 7. And 5 times 7 is equal to 35. 35, the only way to factor 35 would be just 5 and 7. And not one of them is a perfect square, therefore you cannot simplify square root of 35 anymore. So for exercise number 2, the value of x is square root of 10. The value of y is square root of 14. And the value of z is square root of 35. Any questions so far? By the way, uh, for your IXL assignment, the one that I assigned to you last week by mistake, the one that's under P10, uh, most of those problems are these types of problems. Uh, by the way, I want to commend most of you because I knew that you went through trouble uh, doing that assignment, and yet a lot of you bravely did them and were very successful. By actually getting hundreds in that assignment. So that says a lot about you. And for those who didn't finish, well, that IXL assignment is these types of problem. If you have any more question, let me know, and I can make another video to explain to you the problems. Any questions so far?